Discussion today centered on oxidation and reduction. In chemistry, oxidation and reduction occur simultaneously. Based on the definition on the board, there are four ways in which oxidation can be defined. The first definition of oxidation is loss of electrons. For instance, when metals generally give out their outer electrons to the neighboring atom during chemical reactions, their oxygen number increase. For example, let's look at the sodium atom. When sodium atom give out the outer electron becomes sodium ion, which can be given in form of this equation. Na give one electron to become Na plus, and that is plus one electron. This basically the oxidation number of sodium has increased from 0 to 1. Also, let's look at the another metal like magnesium. When magnesium give out the outer electron, become magnesium 2 plus, that is plus 2 electrons. These two definitions indicate that loss of electrons brings about oxidation. Now, the second one is addition of oxygens. Basically, when add oxygen gas plus metal, for example, copper plus oxygen gas give out what we call copper 2 oxide. Balance the equation. You have two here. The equation is balanced. Or when you burn magnesium in the presence of oxygen, it will give what we call magnesium oxide. These two equations indicate that addition of oxygen brings about oxidations. Now the third one is removal of hydrogens. Of hydrogen, let's look at these reactions. When you have hydrogen sulfide plus chlorine gas produce hydrochloric acid plus what? Deposition of sulfur. This reaction is pure oxidation because if you remove hydrogen from hydrogen sulfide to give what we call sulfur, and then therefore removal of hydrogens also brings about oxidations. Okay, addition of non-metals. Addition of non-metal also can also be defined as oxidations. For example, let's look at the reaction between the iron 2 chloride and chlorine gas. When iron 2 chloride react with chlorine gas, it will give what we call iron 3. Let's support it with the equations. You are in the last one. So when you have iron 2 plus chlorine gas, it will give you iron 3 chloride. Balance the equation, then you have 2 here. This is also definition of because here the oxygen number of ions here is ion 2 plus, while has increased to ion 3 plus. This is also what we call oxidation. Now let's now look at this second aspect, reductions. Reduction is just the opposite of oxidations. Here is gain of electrons or electron acceptor. How do you define this? Let's look at the oxygen. When oxygen acquire oxygen molecule, oxygen molecule need 4 electrons to be reduced. That means need 4 electrons. That means plus 4 electrons to not give what we call two two oxygen ions, two molecules of oxygen ions. Or when you have chlorine molecule plus 2 electrons, it will give what we call two molecules of chlorine ions. These two definitions simply means they add electron to the atmosphere. Therefore, itself they will be reduced. This the simple definition of what reductions. Let's look at the addition of hydrogens. In addition of hydrogens, we are going to look at the equation between the reaction between the hydrogen sulfide, reaction between the hydrogen sulfide plus chlorine gas. Therefore, here will be HCl plus hydrogen sulfide. Here, there is addition of hydrogen here. Therefore, this is reductions. Why from here? Okay, from here. Why from here will be from here will be reductions, and this oxidations. This oxidation that is from hydrogen sulfide to sulfur is oxidations. Why chlorine gas to hydrochloric acid will be reductions. Therefore, let's now look at the addition of metal. Addition of metal also brings about reduction. Okay. For example, when you have magnesiums plus oxygen gas, because this oxygen gas, the oxygen number is 0 here, and then when you combine become Mg, so that will balance it. Magnesium to magnesium oxide is oxidations, while oxygen gas to magnesium oxide is a reductions. Therefore, these are the ways in which reduction can be defined. But oxidation and reduction cannot occur without two agents called reducing agents and oxidizing agents. Reducing agents are electron donor, while the oxidizing agents are electron acceptor. In terms of definitions, reducing agents are electron donor. When they donate electrons, itself become oxidized, therefore their oxidation number will be increased. While the oxidizing agents, the electron acceptor, when they accept the electron to themselves, then it become reduced. These are the basic way in which you can define reducing agent and oxidizing agent. Now let's look at the equation that we can use to support that. First, let's look at the reaction between the copper 2 oxide, the reaction between the copper 2 oxide and carbon monoxide, that is CuO plus CO, which give copper atom plus carbon 4 oxide. From CO to C, this is pure reductions. This is reduction. While CO to CO2 is oxidation. Therefore, CO is known as this CO known as what? Oxidizing agent. That's it. Why CO? This CuO is an oxidizing agent. Oxidizing agent. Why CO is known as what? Reducing agents. These are the way how you can identify. Also, in another reaction, you can also use H2S plus chlorine molecule, where you have HCl plus sulfur. This case here is oxidizing agent, while H is a what? Is a reducing agent. Reducing agent. Now the next concept we are going to look at, how do you calculate the oxidation number of atom neutral compound elements in a compound? or ion or complex. These are our next concepts. Now, the in generally neutral atom, the oxygen number of a neutral atoms is equal to zero. For example, when you have sodium atom, chlorine atom, and so on. What I'm trying to say in essence is that when you have atom like sodium, sodium, magnesium, chlorine, and calcium, these are atoms. Their oxygen number equal to zero, equal to zero, equal to zero, equal to zero. That means the oxygen number of a stable atom equal to zero is general principle. But let's now also look at in terms of compound, neutral compound. What are the neutral compound? For example, now what are the neutral compounds? Neutral compound are a compound without charge, sodium hydroxide, H2S, carbon dioxide, carbon monoxide, H2SO4, etc. All these are called neutral compound. Therefore, their oxygen number also equal to zero because they are stable, equal to zero. All of the any neutral compound, their oxygen number equal to zero. But from there, let's now look at how do you calculate the oxygen number of each element in a given compound. These are our next discussions. Let's see, we want to calculate the oxidation number of elements in a given compound. For example, let's look at sodium hydroxide, and then you are looking for the oxygen number of oxygen here. Now, what you just need to do is, since you know that the oxygen number of stable compound equal to zero, and then you add all their oxygen number of each element, you equate them to zero. For example, we have 1 plus x plus 1 equal to 0 because x represents the oxygen number of oxygen. Therefore, x plus 2 equal to 0. X now will be equal to minus 2. That means the oxygen number of oxygen here equal to minus 2. Let's look at the sulfur here in H2SO4. H2SO4. We are looking for the sulfur. Hydrogen is 2 here. That means 1 times 2 plus x plus open brackets minus 2 times 4 equal to 0 because oxygen number of oxygen is minus 2. Therefore, we have 2 plus x minus 8 equal to 0. X minus 6 equal to 0. That means x is equal to what? 6. That means oxygen number of sulfur equal to 6. Now, this is how to calculate the oxygen number of elements in a given compound. The next one, ions. For example, when you have CO3, carbonate ion minus 2, comma, we have manganese minus 1. All these are ion. Now, their oxygen number. The oxygen number of ion equal to the charge on the ion. For example, the oxygen number of carbonate here is minus 2. Manganese is what? Minus 1. But in terms of looking for the oxygen number of each atom in a given ions, how do you do that? You equate it, the sum of the oxygen number, equate it to the charge. For example, let copper equal to x, that will be x plus open bracket minus 2 times 3 equal to minus 2. That will be x minus 6 equal to minus 2. X now equal to what? Minus 2 plus 6 equal to what? 4. Then the oxygen number of carbon here is 4. But let's look at the manganese here. Manganese will be equal to x plus open bracket minus 2 times 4 equal to minus 1. Therefore, x minus 8 equal to minus 1. X is equal to minus 1 plus 8. X is equal to what? Is equal to 7. Now let's now look at the complex compound. Complex compounds such as K2, Cr2, O7. Then you want to calculate the oxidation number of chromium here. Remember potassium is 1. That will be 1 times 2 plus 2x because we have 2 chromium plus open bracket minus 2 times 7 equal to 0 because it's a neutral compound. That will be 2 plus 2x minus 14 equal to 0, which is equal to 2x equal to 12. And then your x now be equal to what? 6.